Dear students, first I wish you all the best in this hard time, and I hope see you all soon safe and healthy. Take care, please, of yourself, your families, and the people you have in contact with. Nevertheless, we should continue to learn via e-learning, and we will continue here with lecture number 4, IT infrastructure and emerging technologies. In this chapter, we will learn to answer the following questions. What is infrastructure? What are its components? This means to learn definitions of IT infrastructure and its components. The second question is which stage and technology drivers for IT infrastructure evolution? And the third point or questions to be answered is what are the current trends in computer hardware platforms? And the fourth one is what are the current trends in software platforms? So we will learn the sorts and kinds of hardware and software platforms in IT infrastructures. And the fifth question is how to manage IT infrastructure and to solve problems that you could face with. IT infrastructure is simply a set of physical devices, hardware and software required to operate the enterprise. This is a pure technical definition of IT infrastructure. From business point of view, this means this hardware and software should deliver services supporting business needs. Business needs could be firm-wide services, including the following: computing platform providing computing services. That means processing of end-user requests from different departments, for example, financial department, to create payrolls, or from sale and distribution department to conduct customer orders and so on. And it's also the need for telecommunication services to reach supplier and customer, or services for data management to store data and analyzing them to take a decision, for example, or services for application software to conduct or to automate day-to-day tasks, physical facilities management services, and also IT management, standards, education, research, training, development services, etc., etc. Services platform perspective, more accurate view of value of investment. This means these services argue why we need IT infrastructure, which add value added for the business through using IT infrastructure to save money, to save time, and so on. New information technologies have a powerful impact on business and IT strategy, as well as services that can be provided to the customer. So IT services and IT infrastructure is a product of alignment of business strategies, IT strategy, and information technology to serve and support customer services, supplier services, and also enterprise services. Now we will learn the evolution of IT infrastructure over the time. It's very important to learn this because nowadays we can see in system landscape of an organization different computer structures from different eras. Um, IT infrastructure and organization today is an outgrowth of over 50 years. Imagine that, of evolution in the computing platforms. There have been 5 stages in this evolution, each presenting different configuration of computer power and infrastructure elements. That's why we should learn this evolution. The 5 eras are general purpose mainframe, that's mainframe era, and mini computer. And the second era is client server architecture or client server network. And the third era is enterprise computing, followed by cloud and mobile computing. And not mentioned in this book, big data era. But we will discuss big data later on in this lecture. So let's begin with mainframe era. Mainframes were actually, or it is a powerful machines that allowed organization to begin to tap into the power of information, to use finally information automatically. Companies were able to automate manual tasks, shorten the time of market for new products, for example, through mainframe technology, run financial models and tasks, etc., etc. However, these high-power machines came with high price. It was very expensive. The mini computer, in contrast, began to bring similar capabilities to lower price, but the mini computer configuration were often over $100,000 as well. The mainframe model consists of centralized computer, that's the mainframe, usually housed in secure climate-controlled computer rooms, data center, and end user interfaced with the computers via so-called dumb terminals. These dumb terminals were low-cost devices that usually consisted of monitors, keyboard, and communication ports to communicate with the mainframe. The mainframe disadvantages were lack of vendor operating system standard. That were just proprietary solutions, that is specific operating system that belong to the vendor, like a IBM operating system. There was no standards for operating system. Expensive, high cost of entry, and it was also potential single point of failure because it's centralized when the failure caused that affects the all organizations. And mainframe using time sharing systems, and because of that it was a potential of bottleneck. That means a negative effect of system performance. The personal computer era in the 80s and last centuries It was introduced by IBM, and actually it addressed to private people to use a computer as a personal computer. And in this time, it was revolutionary for private people to use computers, and also for the companies. They have seen this as a chance to use a PC, private computers, for organizations. And in this moment, or at this time, the idea of client-server network or client-server era was born, to use a desktop client's personal computer network to servers with processing work split between clients and server. In contrast to mainframe, which is processing all the workload, here the workload is split between the clients and the server. Client-server computing contains desktop or laptop computers called client are networked to powerful server computers that provide the client computer with a variety of services and capabilities. So server normally contains data, business application, and the main functions, computer programs needed by the clients. The clients asking for services, so the server deliver the clients with services needed. That is why this sort of architecture called client-server architecture. The term of server refers to both the software application and the physical computer itself, on which the network software runs. The server could be mainframe, but today server computers typically are more powerful version of personal computers. So here we can see an example of 3 eras. Mainframe, it is a big supercomputer, powerful, connected to dumb terminals. The dumb terminals, they have no functionalities, just graphical user interface to connect to the mainframe. And in the middle of the figure, we will see personal computer. They are normally separated or connected. And finally, at the bottom of this figure, we can see client-server network. There are many desktops are connected with a server. In 1992 began the era of enterprise computing. Enterprise applications are standard software solutions, packages, software that support business processes of any organization, as we have already learned in Chapter 2, like ERP, CRM, and supply chain management systems. Thereby, enterprise systems, for instance, integrate all departments and its own networks using the internet with a standard internet protocol, namely TCP/IP. In the cloud era, from year 2000 to present, cloud computing refers to a model of computing that provides access to a shared pool of computing resources, computers, storages, applications, and services. This model used a network, namely internet, and providing the customer its product or resources as services. These clouds of computing resources can be accessed on an as needed basis from any connected device and location. Currently, cloud computing is the fastest growing form of computing with a company. Software firms such as Google, Microsoft, SAP, Oracle, and Salesforce sell software applications as service delivered over the internet. Cloud computing services could be software or platforms, even networks that could be sold to the customer. In this figure, we see the last two eras of IT computing. In the top of that figure, we see a typical network of enterprise computing. We have enterprise server, and normally this server hosted database, all the data of the enterprise integrated in one server, and application that could be accessed by different departments. This means different sub-networks of an organization. And in the bottom of this figure, we see a cloud model, which is a cloud provider deliver his services to the customer, to organization, and this organization can use these services. Service, as we said before, could be software, platforms, networks, or even data. This figure illustrates multi-tiered client-server networks. Client requests for service are handled by different level of server, so that we see here a different kind of computers. Client, it is a desktop, a simple computer. It is normally UI, user interface, to access on different server. Using internet, we can access web server that hosts web management application like Apache, for example, to manage websites and access authorities of user and so on. Regarding web application. So that's why we call it web server. Application server hosting normally business application like ERP system, supply chain management system, customer relationship management system, and so on. That's why we call it application server. And finally, we see here a data, and normally hosted by database server. It hosts database management system. So we call every server depending on the kind of software installed in it. So now moving to driver of infrastructure evolutions, which factors promote emergence of IT infrastructure. First of all, Moore's law and microprocessing power related to three factors. First, computing power doubled every 18 months. Nanotechnology shrank size of transistor to size comparable to size of a virus. That means we can use small computers as tablets and laptops for mobile business and so on. Law of mass digital storage, amount of data being stored each year doubles. We can now in organization store more data about customer tracking, customer behavior and analyzing them, because we have now the capability to store more data. As we can see here, how the processing power related to number of transistors. So with the time, the empowering of computing is increased with the time, and the number of transistors also increased. Packing of over 2 billion transistors into a tiny microprocessor has exponentially increased processing power. I would like to pay attention to you. I will not asking you about such diagrams. It's not. It is just to demonstrate, to illustrate how the empowering of computer increase with the time. That's all. The same for this slide to demonstrate that is the computer become cheaper with the time. So it is not every organization can afford it nowadays. That's all. That is falling cost of chips, for example, as a factor to promote IT infrastructure and using them. So it's not here, it's not really important for us. The cost of storing data declines exponentially. As I said before, it becomes cheaper and every organization can afford it nowadays. So the same, it is actually valid for the power of network. The value or power of a network grows exponentially as a function of the number of network members. It is important for you to understand that is we have now our network become cheaper with the time and more powerful. That's all. Consequently, declining communication costs and the internet. And through that, any organization can use communication, networks, and internet with a cheap price, and they can concentrate on own business and customers. Now coming to the component of IT infrastructures. As we said before, we have already defined IT infrastructure as a set of hardware and software that operate an enterprises. Which component that IT infrastructure has? Computer hardware platform, operating system platform, enterprise software application, data management and storage, networking, telecommunication platforms, internet platforms, and consulting system integration services. So, one by one, we will explain all these components. So, the first one, computer hardware platform, that is pure hardware. So we have hardware as a desktop, client machines, and server. It could be a normal desktop with powerful resources like powerful CPUs and main memories and huge storage, or flat server. It is ultra-thin computer stored in so-called racks. Mainframes, we have already learned what mainframe is, and we see here a list of producer and firm delivering this hardware. That's just for your information. So, coming now to operating systems. Operating system now in market restricted on just a few vendors. We have Windows. About 750% of all running operating system based on Windows platform, Windows operating system, and the rest about 25 run Unix or Linux. But I have to state that in last year more and more organizations using Linux because it become more stable and it's more cheaper. At the client level, more user using Windows, Android for mobile devices, and for cloud computing there are special operating system like Google's Chrome operating system. So we have the third, now we have the third component, enterprise software application. We know, I hope, we know now what is enterprise application. This is enterprise system like ERP system, supply chain management system, and enterprise customer relationship management system. The main provider of these systems are, or the market leader are SAP and Oracle. For the middleware provider, there are BA and Salesforce. For cloud computing user, it is more and more enterprises from the middle tier using these solutions. Database software or database and storage. We have also here database software and a physical hardware. Database software like Oracle, Microsoft, Sybase, IBM, and so on. A physical data storage, it is hard disk, as we have in our computers, from different vendors like Seagate, Maxtor, Western Digital, and so on. And there are storage area network, how to connect all these devices to each other using a special kind of network, connecting multiple storage devices on dedicated network. And the next component is networking telecommunication platform. That is a telecommunication. We need a telecommunication services from different vendors in the market, like AT&T and Verizon. We need also software, not just telecommunication cables and telephones company charges for voice lines. We need also network operating system like Windows Server, Novel, Linux, and Unix. The hardware provider like Cisco. We know Cisco, I think it is the market leader in the network technology, and so on. So, internet platform, hardware and software, management services to support company websites. So, what I need when I want to develop my own web server. So I need internet hardware from Dell, HP. I think I will not asking you about the vendors. It is more important now to understand the component and the functions of each, not about which is vendors deliver which product. So the last component is consulting and system integration services. Even large firms don't have resources for all full range of support for new complex infrastructure. This sentence indicates that is any large firm need consulting from consulting firm because they have a very complicated IT infrastructure. They have old system, we call legacy systems. Legacy system, they are old. TPS created for mainframes that would be too costly to replace or redesign. So that is normally old system. It's not just mainframes. It could be other systems that the employees familiar to this system, they are working with this old system for years. And now imagine that an organization want to introduce ERP system, but they want to keep the old system, this legacy system. How to integrate the legacy system into the new system landscape when we introduce ERP systems. That is the role of consulting firm. They put their knowledge and experiences to integrate legacy system in the new system landscape. Many vendors also supporting ERP vendors supporting firm to integrate legacy systems like SAP or Oracle. Now we will explain the next topic of this lecture regarding the merging of mobile digital platform as one of the current hardware platform trends. So we will handling platform trends. The first topic is emerging of mobile digital platform that can be used, for example, by sales force in sales department. They need mobile devices to show the customers, for example, demos, or to communicate with the firm, with the warehouse, to see if there are some products already available in a warehouse, for example. So they need mobile devices like cell phones, smartphone, notebooks, tablets, and so on. The second trend, so the next trend is grid computing. Grid computing is simply connecting graphically remote separated computer into single network to combine processing power and create virtual supercomputer. So to build up a supercomputer from different separated computers together to be appear as one. We do this to save cost and to increase performance, processing performance. Virtualization, it's a technology to be used in a server, slicing server, small pieces, and each piece could be contain different operating systems. Imagine that you have your own desktop and you can work with this desktop with a different operating system. For a piece for Unix, a piece for Windows, a piece for Linux, and so on. So virtualization can be used in data centers to computing requests from the user and increase usability of the computer, to reduce hardware and power expenditure, to facilitate hardware and centralizing them. Cloud computing, as we said before, it is a business model. On-demand computing services obtained over network. So we can deliver services, infrastructure as a service, network as a service, even platform as a service, and software as a service. Even ERP system, we can provide it over the internet using cloud computing as a service. Cloud can be public or private. Public, that means there are some provider, cloud computing provider. There are public for any organization, that any organization can buy a software over the internet from this vendor. A private cloud, that is, an organization has its own data centers, and these data centers operate with the principle of cloud computing, and they normally using thereby virtualization technologies. Allows companies to minimize IT investments, so I don't need too much hardware because I use actually my resources, my hardware optimal. Drawbacks concern of security and reliability. Security, if I access on external party as cloud computing provider, there are some kind of risk because I share devices with other clients, and the same resources. So many companies, they are aware about this point. So the next trend is green computing. Green computing reflects actually the awareness of society and industry in a country about environments. That is, practices and technologies for manufacturing, using, and very important, disposing of computing and networking hardware to reduce emissions, CO2s, and environmental indicators for green product. It's not just linked to IT industry, but also for the industry in general. And the next point or the next trend is autonomic computing. That is how IT system can heal themselves automatically. So, for example, to install some software agent to update antivirus systems online and to permanent investigate some hacker or intruders. So there are also high performance power saving processors like a multi-core processors, but I think that's not normal nowadays. Open source software, it's trends in the last years. Open source software normally has its own communities. They permanently, continuously improving the core and functionalities of such open source software, and they become with the time more matured and reliable. So many enterprises, especially small medium enterprises, are using open source software like Linux as operating systems. It becomes more stable and reliable, and many companies use it. Or MySQL as a database management systems. There are also software for the web. Web is very important for any organization today, and there are many functions and tools, softwares can be used in this environment, web environment, like Java. Java is object-oriented programming language. And there are other, it is operating system processor independent. It's totally standard and portable for any IT infrastructure. There are also Ajax. Ajax, it's a container based on XML documents to exchange data between information systems. So there are also web services. Web services, that's standard how information system can be communicated over remote calls. And there are many components involved in web services technology. XML, extensible markup language, it's just a document structured and can be understood by machines automatically. It's more powerful and flexible than HTML used by web application. And it's actually addressed to machine communication between machines. SWAP, it's a simple object access protocol. It's a protocol developed for exchanging of data, rules for structuring messages, enabling application to pass data and instructions. WSDL, it's a web service description language. It is describe actually the functions hosted in external information systems. It's just to show the name of the function and the parameter, the input parameter and the output parameter can be delivered by such function. It's a framework for describing web services and capabilities. It shows which function from business point of view, logically it is explained, and also technical explanation how to be accessed from outside. UDDI, Universal Description, Discovery and Integration. It's just a directory for locating web services. It is like a yellow page, so you can see which web services are allocated in which address or which external information system. Service-oriented architecture, it is a concept that can use web services provided by information systems, by legacy systems, internally within the organization or external from our business partner as a supplier or customer. So these web services can be assembled to work together to deliver application. So formally, it is a set of self-contained services that communicate with each other to create a working software application. Software developer reuse these services in other combination to assemble other application as needed. For example, invoice service. Invoice service can be used as an application to serve the whole firm for calculating and sending printed invoices. So I can use many web services, combine them together as application supporting invoice service. Or for this, the firm $rent a car uses a web service to link online booking system with Southwest Airlines websites. It's a typical example how we can use service-oriented architecture. So for airlines firm, for example, when you book a ticket, this ticket contains many airlines related to different routes. Every route carried out by different airlines. When you take this book this ticket, the booking runs over information system of the related airlines, and the booking them together as a service-oriented architecture function or application. That is an example of $rent a car, as you can see here. So other trend to use techniques and technology to create websites and application and apps. What is mashup? Mashup created when individual user and companies mix and match software component to create their own customized application and to share information with others. So software component will be combined with using mashup technology based on Web2 technology that we will study this later on. And the other technology or techniques can be used in web area is widgets. Widgets, small software programs that can be added to web pages or placed on the desktop to provide additional functionality. So we can see this in many web sites. They embedding, for example, Google Maps as a functionality. They didn't develop the Google Map, but they can put it in their own websites using widget technologies. There are also apps. We know apps. We can use it. Small pieces of software can be installed on our mobile devices, for example. Now we come to outsourcing topic. It's a trend nowadays to save money. First of all, we want to discuss kinds of software. There are software packages like enterprise system and enterprise software. So an organization can buy a software packages and deploy it in the organization and use it simply. To do this, we need IT department, we need IT expert to operate just software packages. It's normally expensive and need resources. Software outsourcing, we can outsourcing resource, domestic or offshore. Domestic, that means primarily for middleware, for service-oriented architecture, for example, integration services, software support. They can outsource it for the firm, this firm working in the company. They are working in the company and maintain the middleware and integration services. Offshore, in contrast, primarily for lower level maintenance, data entry, and so on, call centers, so I can outsource it outside the boundary of the organization to be processed by third party. So the third external sources for software is cloud-based software services, software as a service. So we use cloud computing to reach or to deploy our functionality remotely. This means the application hosted by third party, by cloud provider, and as a software as a service, accessed with web browser of the internet, with web application, and then or by a client software. So you can use both. Either you use a web browser or use a client software to connect a cloud. So in order to do this, you have to make so-called SLA, Service Level Agreement. It's a formal agreement with the service provider to assure and ensure the quality of the services and to state the financial aspect of these agreements. So coming now to management issues related to IT infrastructures and all problems coming with. For example, the problem of growing of IT infrastructure with the time. So as firm shrink or grow. Shrink, this means will be streamlining, or in contrast grow. IT needs to be flexible with these new requirements and scalable. Scalability is the ability to expand to serve larger number of users. To do this, we have to manage, first of all, policies and procedures, rules, and responsibility for managing these new platforms, like mobile computing and cloud computing, for example. Contractual agreements with firm running clouds and distributing software required. Contract, as we said before, like SLEs, service level agreements. Who actually controls IT infrastructure? Who is responsible for? How should an IT department be organized? There are two types of organization of ITs. Centralized, this means there are some entity centralized as IT department makes decisions. They are responsible for all IT of an organization. Decentralized, that means business units. IT, for every department in organization, has its own IT department, and these IT departments makes own decision. So the problem here, how are costs allocated between divisions and departments? The amount to spend on IT is complex questions. Considering rent versus buy and or outsourcing. First of all, to do this, to decide if we rent some IT infrastructure, IT component, or buy it, or even outsourcing it, we have to calculate the cost. And normally that's based on so-called TCO, total cost of ownership. Total cost of ownership, it is not just the direct cost of physical component, for example, for information system or database system, even of the cost of a server. But it's more about the indirect costs, like installations cost, training, supporting, maintaining, and all this stuff. It makes up about 80% of the total cost. Total cost can be reduced through use of cloud services to outsourcing in the cloud, or for greater centralization to streamlining ITs and IT department, and standardization of hardware and software resources to be able to communicate and integrate it. So this is a chapter summary. We learned IT infrastructure, what is IT infrastructure, definition of IT infrastructure, and the components of it. What are the stages and technology drivers? It's a very important driver that promotes the emergence of IT infrastructures. And the third point we learned today, what are the current trends of computer hardware platforms and what are the current trends of software platforms. And finally, we learned challenges of managing IT infrastructure. I hope you understood the main point of this lecture. If you have any questions, please connect me, send me an email for your questions, and I promise I will answer you. So, best of luck, take careful of yourselves and your family, and I hope I will see you soon. Bye.